Okay, we're just going to look at a hopefully quick one on changing our interest rates. Okay, so changing the different interest rates depending on the length of time that I have. Okay, and what we kind of call that is the compounding period. So when we're looking at our interest or depreciation or whatever it is that we're looking at, investments, loans, whatever it is, we'll be given a general rate for that. And sometimes they'll call it the annual equivalent rate or the annual percentage rate, or they might call it the monthly rate. It can depend on the question. The compounding period here refers to how that interest is calculated or how often it is calculated. So a lot of the time that will be annual, but it could be monthly, it could be quarterly, it could follow some other particular pattern, it could be after 9 months. So it really just depends on the question and the individual circumstance that we're looking at. And we need to be able to adjust our questions here based on the rates that I need. So if I want monthly compounding period, then I need to be able to adjust my question to have monthly compounding rates, okay, and so on and so forth. So it's just important to be able to adjust based on the question. So if we want to find a monthly or a yearly or quarterly or whatever equivalent rate, what we need to do is we need to start by looking at kind of comparable final values here. And what I mean by that is I'm saying that after 12 months, I should have the same amount of money as if I was saving for a year. So if I was saving for a year or saving for 12 months, I should have the same amount of money. What that means is P times 1 plus R for 12 months should be the same as P times 1 plus I for a year. And we end up with this kind of expression here, which is the main expression we're going to be using. So 1 plus R to the power of t should equal 1 plus I to the power of t, where each value of t there on the left or right matches up with the compounding period that I'm looking at, and both are cover the same length of time. So you can see here 12 months 1 year, 52 weeks 1 year, one block of 8 years matching up with 8 years overall. So we're always just matching up the rate with the individual kind of length of time there that we have. We have another way as well, which is to express the final value as a percentage relative to the original value and then use my formula. We kind of end up with the same result or the same method really either way. So calculate the annual equivalent rate on an investment which has a return of 30% after 6 years. So what they're really telling us here is that for a length of one block of 6 years, the rate that I have is 30%. Okay, so 1 plus R to the power of t equals 1 plus I to the power of t. So we're saying 1 plus 0.3 for one block of 6 years should be the same as whatever my annual interest rate is, and that's for 6 years. So one block of 6 years as opposed to 6 individual years. So the compounding period for one of them is just after the 6 years I get 30% more. The other one is each year for 6 years. I'm calculating that interest. So that's 1.3 equals 1 plus I to the power of 6. What I need to do now is I'm solving for I, so I'm going to take the 6th root of 1.3, or rewrite it as 1.3 to the power of 1 over 6. And because I'm trying to solve for I here, I'm going to get rid of the 1 there as well from that side. So filling all of that really into my calculator then, 1 over 6 minus 1, sorry, let me just make sure that's out of the power there, much better, 0.0447. Okay, and we end up with an annual interest rate of 0.0447. If I want to write it as an overall rate, it's 4.47%. Okay, let's look at another example. Find for each of the following the equivalent rate for the given compounding period. So if I'm doing a compounding period of, or if I have an annual rate of 5% and I'm compounding monthly, so let's set it up. So 1 plus R to the power of 12 should be the same as 1 plus I for 1 year. 1 plus R to the power of 12 is the same as 1.05 for 1 year. 1 plus R to the power of 12 equals 1.05. I'm going to take the 12th root, which is the same as writing that as to the power of 12, and then I need to subtract 1 from my overall answer to work out the value of R. So let's just compute that then. So 1.05 to the power of 1 over 12 minus 1, and that gives me an overall answer of 0.004, okay, or a rate of 0.4%, which kind of lines up. If it's 4% annually, it's less than 1%, less than 0.5% monthly there. A monthly rate of 0.24%, so let's count that. It's going to mean that or is, and if we're unsure, we could type it straight into our calculator, 0.24%, just to see what that gives me. And that gives me 0.0024. So 1 plus or for 12 months is the same as 1 plus I for 1 year. So matching up rate with the compounding period, that's 1.0024 to the power of 12 equals 1 plus I. So I equals 1.0024 to the power of 12 minus 1. And let's see what that gives me. So 12 minus 1. And that's going to give me an answer of 0.029. So an annual rate of 0.029, which of course then is an annual rate of 2.9%. The last one here then, annual 7% and compounding quarterly. So quarterly is going to mean that for a length of time of 4 quarters, that's going to match up with 1 year. So 4 quarters in 1 year. So looking at the same idea again, 1 plus or to the power of 4 is 1 plus I to the power of 1. 1 plus or to the power of 4 is 1.07 to the power of 1. 1 plus or equals 1.07 to the power of a quarter, getting that fourth root. And or is 1.07 to the power of a quarter minus 1. 0.017, which of course is a rate then of about 1.7%. So quarterly rate of about 1.7%. Okay, it's just important in all of these questions, and you can even see it in the exam questions that we have here. There's only really 2 of them to look at. The government's Nationality Solidarity Bond offers 41.7% net return after tax after 10 years. Calculate the annual equivalent rate for the bond. So what we're kind of saying is for a time length of 1 block of 10 years, the rate that I'm working with for that is 41.7%, which is going to be 0.417, and that matches up with a time of 10 years and an interest rate I of I. So 1.417 for 1 block of 10 years is the same as 1 plus I for those 10 years. So I'm going to need to take the 10th root of this left hand side, so 1 over 10, and subtract 1 to find the value of I, and my overall value of I then 417 to the power of 1 over 10, and subtract 1 gives me an annual rate of 0.035, which of course is a rate of 3.5%, which does kind of line up with an overall kind of yearly rate across 10 years of 41.7%, so an annual rate of 3.5. One last question then. A bank has offered a 9-month fixed term reward account paying 2.55% on maturity for new funds from 10,000 to 500,000. You get your money back in 9 months' time along with 2.55% interest. So the idea here is that for 1 block of 9 months, that's going to be an interest rate of 2.55%. which if we really want, we can rewrite as a decimal of 0.0255. Now we just need to kind of really consider how we're going to match up the lengths of time here. Okay, so we need to rewrite this kind of block in terms of a year. So we need to consider 9 months is kind of what fraction of a year here. Okay, and how many of these blocks, I suppose, can I fit into a year? Or alternatively, we can kind of go at it from the yearly side and adjust our yearly length of time instead. So say we go with our year. Instead of having 1 year, have only got 9 months out of my 12 months, which is going to be 3/4 of a year. So we could go with that. 3/4 of a year matches up with my 1 full block of 9 months. And the interest rate that I have is the thing that is unknown so far. So 1 plus or for my 1 block of 9 months is the same as 1 plus I for my 3/4 of a year. 1.0255 equals 1 plus I for 3/4. So let's just get the 3/4 root, if you like, which would be 4/3, 1 plus I, and I is 1.0255 to the power of 4/3, take away 1, and I can use that to work out my overall value then for I, which is 0.04 or 0.0341, which is an interest rate of 3.41% as required. So a nice interesting adjustment there in the last one where we can't exactly match up that time rate, so we need to adjust the year and write it as a fraction of a year as opposed to a full year to match it up to the one block of 9 months. The other thing we could do then is kind of consider that further ideas. So we're taking maybe a block and a third, so 1 1/3 blocks, which of course would be then 4/3, so 4/3 on the left hand side, and leaving the right hand side as just 1, and we would end up with the same result overall. But very important across these questions to be able to convert those interest rates.